Hi, ladies and gentlemen, this is Mr. Green, and this is my Class Connect for Monday. I am sorry I cannot be with you. I am presenting a STAR test today, and if you're taking a STAR test today and you're watching this sometime later on, well, we got Monday and Tuesday in which we will be able to make up any work that we needed to do there, okay? So we're finishing up Unit 3. We're going to look at area and volume ratios, and then we're going to do a quick review of the stuff in Unit 3 so that you can take the Unit 3 test this week, okay? Don't forget, quiz corrections are out there. If you want to make corrections to a quiz, just open it up in the grade book, make the corrections to it that you need to make the corrections in a document that you need to make, and send me that document through the corrections Dropbox. I do give points for that. It does help your grade, so don't let it go. You can do corrections to anything other than the Part 2 test and the discussion. So just get out there and make the corrections to anything that you've got a failing grade on. It will help you. Due dates 28 days after an assignment has been listed as being due, it closes up and then you won't be able to get into it again. So you want to make certain you don't leave any zeros in the grade book. Get them taken care of. Okay? So when we're talking about volume and area ratios, we have a scale factor. The scale factor is simply the ratio of the sides. In this particular situation, we've got a 14/7 scale factor, right? Well, that's actually 2/1. That's the big to the small, the scale factor. If we want to know the area, surface area, right? So surface area ratio, we're going to take that scale factor and we're going to square it. If we want to know the volume ratio, we're going to take that that scale factor, and we're going to cube it. That's the way you find the ratio of the surface area and the volume, or area and volume. It won't make any difference what you're talking about there, okay? So we're looking at prism A having a volume of 1120 cubic inches, and we're wanting to know the volume of prism B. Well, look at this. My scale factor is 2/1. Scale factor is 2/1, right? I'm going to cube that to get my volume ratio. So that's going to be 8/1. Well, the bigger one is 8, obviously, 8/1. So if I say 8/1 is equal to 1120 over our unknown value, using means and extremes, we can say 8x is equal to 1120, or 1120 divided by 8 is equal to whatever our x is, the volume of the smaller prism. So we can do that with a calculator. I mean, I'm not real good with my 1120s. I don't remember those off the top of my head. Do you remember your 1120s? No. No one in my house, remembers their 1120s all that well. So what I'm going to do is I'm going to take a calculator here, clear it off. I'm going to take 1120 and divide it by 8, and I'm going to want helps to use the right number. 1120 divided by 8. You hit enter on it, and you get 140. Guess what? My volume for the smaller prism there is 140 cubic inches. That's inches cubed. And that's how you can use that scale factor to do it. And all I did to find that scale factor was use the ratio of the sides, right? That's how much it dilated. That's how much it grew. However you want to look at it. Okay? Does it work for cones too? Why, sure it works for cones. I can even use the heights on the cone. So I can say the scale factor here is 12/15. That's my scale factor. Okay? So if I wanted to find the volume of cone U, well, they're telling me U is 256 pi. And we're wanting to find this one over here. This is the one we don't know. So what am I going to do? I'm going to take 12/15. Oh, wait a second, that reduces. So I'm going to reduce it first to take a 3 out. 4/5. Now I'm going to cube that. So I'm going to say 4/5 to the third power is equal to 64/125. And then I can set up a ratio, proportion. 64/125 equals my smaller one, 256 pi, divided by x. We don't know what x is. So simply using my means and extremes, I'm going to take 64x is equal to 125 times 256 times pi. So x is going to be equal to 125 times 256 times pi divided by 64. Well, I can do that on the calculator, right? So I'm going to take 125 times 256 divided by 64. And I'm not even going to take the pi in there. I'm just going to leave it like that. It turns out to be 500. And bringing that pi down because I didn't even put it in the calculations, did I? 500 pi centimeters cubed. Okay? Now I realize I've done two problems here that are volume problems and haven't done a single one that's a surface area problem. So I want to go back to this one. What if they gave me a value for surface area here? Okay, so what if I went back to this one here? What if I said this basis was a 4 by 20? Well, just to show you that this is going to work, I'm going to say 4 times 20 times 14. Which should be the volume, and that's 1120, right? So I've got the right dimensions here. So let's find the surface area of this one real quickly. That'd be 20 times 4, that's 80. There's going to be two of those, so I'll say 2 times 80 plus 4 times 14, that's 56. That's 2 times 56. And then 14 times 20, that's 280. I'll be multiplying that one times 2. So plus. So what have I got here? I've got 160 plus 112 plus 280. That's 560. And adding that all up, I get 6, 7. That's here. It's going to end up with a 2, 6, 7, and 6 more. It'd be 13. Carry your 1. 6, 7, 8. 832 inches squared. That's their inches squared. Now, do I have to go through the same process on the prism B over here? No, because my surface area, remember, if I square it, I'll find the area ratio. My my scale factor was 2 to 1. If I square that, I get 4 to 1, right? So I'm going to take this number here, 4 over 1. That's the area, surface area, area ratio, will be equal to 832 over x. So you just multiply it, using your means and extremes. 4x equals 832. Divide by 4. X is going to be equal to 208. Yes, 8. So 832 divided by 4. Oops, didn't want to do that. I'm sorry, I wanted that one. Okay, 832 divided by 4 gives me a 208. So that's 208 inches squared on this one. So we found the surface area too. And that was simply by, taking the surface area of one of them and using the scale factor to scale it down. Okay? Same thing could be done with the cone there. But I want to go back and I want to make certain I cover some topics that are in the entire unit so that you're prepared for the test. If I was wanting to set up the ratios for this one, okay, it's a side splitting theorem. It tells me that PA is 8 and that PR, that's this whole distance here, is 24. And over here, this whole distance over here is 6. This is the one we don't know right there, right? So we can say 8 divided by 24 is equal to x divided by 6. Means and extremes. 6 times 8 is 42 is equal to 24x. X is equal to 42 divided by 24. Well, I don't know that one off the top of my head, so I'm going to do this. 42 divided by 24, and that gives me 1.75. Or if you wanted to look at it as a fraction, you can do it this way and you'll get 7 over 4. Okay? So I get 7 over 4 as an answer, 7/4 or 1.75. So x is going to be equal to 1.75 or 7 over 4. That's what this distance here is. Okay? No problem. Wait a second. That's not right. I'm sorry. I'm going to back up there. I've made this mistake before. And I recognize since this whole distance is 24, that means that this distance here is 16. And that means that we don't know what this distance is right here, do we? But we do know that it's 8 over 16 is equal to x divided by 6 minus x. That's the way we should be setting that up. And then when we multiply it out, we should get 6 times 8 is 48 minus 8x is equal to 16x. Well, add the 16x to both sides. I still get 48 is equal to 24x. Oh, okay. So x is still equal to 1.75 or 7 over 4, right? We got the same answer. I just wanted to show you. It didn't matter if I was using the entire length there or just this part of a length here. It worked out to be the exact same answer in both those situations. That's what the side splitting theorem allows us to do. Okay? And it's all because these sides are parallel to each other. What else do we get when we get parallel sides? We get equal angles. Remember that? Because this angle will be equal to this angle. Why? Because they're corresponding angles. Remember that sort of stuff? Okay? Want to make certain you remember that one. Okay, this one's a little bit easier. This one is a cell tower. And if you draw a line from the cell tower like this up to here, like that, and you put a stake in the ground like this, okay, and you measure the height of that stake, you can find the height of the cell tower. Okay? Now, how do we go about doing this? Well, typically this is done with shadows. So there'll be a shadow that's cast on the ground. Okay? And they'll put a stake at the end of the shadow, and they'll come over here and they'll back up a few meters, and they'll put another stake in the ground that's at the same height as the shadow, and they'll know the stake here is 4 meters high and that it's 5 meters from it, and the distance from here to there is 45 meters. Now, why is that whole distance important where it wasn't important on that other one? Well, we're not using two sides here and doing side splitting. We just have to go back to our regular triangle similarity proportions here. And so I have to use the sides of the triangles, not just the parts of the triangles. Okay? So in this situation, I'm going to have the height of the cell tower, which we don't know, divided by 45 is going to be equal to 4 divided by 5. Means and extremes, right? So we get 5x is equal to 160 and 20, 180. And we divide by 5. X is equal to 20 and 8, 28. Is that correct? Let's see here. 45 times 4 is equal to 180. Yep, that's right. And then I divide that by 5, divided by 5, and I get 36. Wow. 36. So this cell tower is 36 meters high. Cool? Okay. Looking at this one. This is one of those ratios where you see these marks right here. That's telling me those are equal in length, right? So that means that AD and AG are both medians. Medians were one of those other things that we could set up in ratios, okay? So when they tell me that AF is 16 and FE is 4, and they give me AG is 12, all I've got to do is say 16 divided by 4 is equal to 12 divided by X. We don't know what it is, but it's GD right here. Okay? Well, we can now do a little bit of means and extremes, and I'll get 48 is equal to 16x, and x is equal to 3. So we found that distance right there to be 3 using the median. Okay? Now this one, pentagons. They're telling us that these pentagons have a 12 to 28 ratio. 12 over 28. Okay? And they're similar. Okay? So what's the scale factor of the large to the small? Oh, wait a second. Large to small. We want to make certain we put it in the other order. 28 over 12. Well, those reduce, right? Okay, we can take a 4 out of both of them, and that becomes a 28 divided by 4 is 7. 12 divided by 4 is a 3. So I get 7 over 3. So they're asking me, what's the ratio of the area? They're not asking what the area is. They're asking what the ratio of the area is. Well, what I'm going to do is I'm going to take 7 over 3, which is the scale factor, and I'm going to square it. And I'm going to get 49 over 9. That's the way I would set that up and the way I would find that scale factor of the areas. Large to small. It means it gets smaller. And that does. 49 over 9 gets smaller. That's less than 1. Oh, wait a second. That's greater than 1, isn't it? If we wanted it to be less than 1, we'd flip it around the other way. 9 over 49. Yeah, well, you get the idea there. Okay, if we're doing a dilation from this one, the pre-image is the first one. So if they're giving me the pre-image of A, E, B, let's do that in yellow. A to E, E to B, B to A. That's the triangle. That's the pre-image. And the image is the one that it expanded to, right? And they want me to identify some points, okay? Well, B is on the pre-image, E is on the pre-image, A is on the pre-image. A is on the image, D is on the image, and so is C. The image points would be D and C and A. Okay? And what kind of a dilation is this? Well, if it gets bigger like that, then it is an expansion. E-X-P-A-N-S-I-O-N. Expansion. It got bigger. Okay? It enlarged. It got bigger. Okay? That's what kind of an expansion it is. And the reason I know that it did that is they gave me the pre-image and the image information. And it looks like it gets bigger. It just gets bigger like that. Okay? Okay, if I'm just given points like this point here, 2, 2, and negative 1, 3, and then they're asking me it's dilated to the image segment within points at 2, negative 6, and at 4, 4, and they're asking me is the scale factor greater than 0 or less than 0? Well, you know what? It gets bigger, doesn't it? So because it gets bigger, it's greater than 1. And because it's greater than 1, it must be greater than 0. Okay? If it had been less than 0, not only would it have gotten a little smaller, but it would have gone on the other side of the origin. 0, 0 would have gone over here. Because that's what it would take for a dilation to get small, to go negative. It has to go on the other side of the lines. Okay? So, the volumes of two similar solids are 20 and 540 centimeters. I'm just going to write that down. 20 over 540. Okay? The ratio of the corresponding sides of the larger figure to the smaller figure. Well, they want it larger to smaller. Turn it around. 540 divided by 20. And they want me to reduce it. Okay? So that's going to be a 17 over 1. Okay? That is 540, 27 over 1. Jeez, Mr. Green. That's 27 over 1. That's the ratio of the volumes. All I did was reduce that ratio down. But if they want the ratio of the sides, what I have to do is I have to take the cube root. Okay? Cube root of 27 over 1. Well, the only way I can do that is on the calculator. Okay? The only way I can successfully do that is on the calculator. If you press math and do a number 4, it gives you the cube root, and you can say parenthesis 27 divided by 1, and it will tell you that the cube root is 3. And so you're going to have a 3 to 1 ratio of sides. So when you take the cube root, you get 3. Okay? Now, are there other ways to take cube root on a calculator? Sure. You can say 27, and I want to raise that to the 1/3 power. That's what it means when you're taking the cube root. You get the same 3. Cool? Going forward. On the coordinate plane, the origin is a center of a contraction with a scale factor of p, and they want to find the coordinates of the images for the pre-image points. For the image points from the pre-image points. Okay? The pre-image points were x and y. What you're going to do is you're going to be multiplying p times x and p times y. That's what the scale factor does, okay? And so if it is a contraction, it doesn't make any difference. It's just going to be multiplied together like that. If it's less than 1, that's what p will be. It will be less than 1 because it's a contraction, and it will make it shrink down a little bit. And that's how you can find the new coordinates. Going forward. So, similar triangles. Angles equal in 2 different triangles. So we've got 2 different triangles like this, and we've got to have at least 2 angles on these 2 triangles that are equal to each other, 2 corresponding angles that are equal to each other. Okay? If you've got sides that are in ratio to each other, you've got to have the angle in between them typically. Side angle side. Or all 3 sides that are in ratio to each other. Now it says all are in proportion. That means all the ratios would be the same. Okay? Here's another example of a problem you might face. If I've got a building and the shadow of the building goes right through that flag right there to hit the ground, and I'm trying to figure out how tall the flagpole is. I know my building's 76 meters high. 76 meters high. I know that the building is how far away from that into the shadow? Well, that's 57 meters. How did I get 57? I added 48 and 9 together to get 57. That's how far the building is from the end of the shadow. Well, the flagpole is also 9 meters away from the end of the shadow, but we don't know how tall the flagpole is. So it's now just a matter of doing means and extremes. 57x is equal to 9 times 76. Or the flagpole is going to be 9 times 76 divided by 57. Let's bring that up and do it on a calculator. Clear out the calculator. 9 times 76 divided by 57, and we get a total of 12. X is equal to 12 meters. So this height right here is 12 meters high. You guys getting this? Okay. Ratio of the sides. They want me to tell you what the ratio of the sides are. Well, it's 45 divided by 36. Wait a second. 9 goes into both of those, doesn't it? So that's 5 over 4. That's my ratio of the sides. What's the ratio of the area? Well, you know what? Area of the bases. All I got to do is take 5 over 4 and square it. 25 over 16. And what's the ratio of the volume of these cubes? I take 5 over 4 and I cube it. And I'll get 125 over 64. Okay? So it's not like these ratios are secret or hard to get to, are they? It's just a matter of finding two sides that are corresponding sides, writing down the ratio, simplify it, square it, gives you the area ratio. Cube it, gives you the volume ratio. I'm stressing that a little bit because there are a lot of people who miss that one, okay? Okay, looking at this one. If I set up the ratios on this one, I get 5.2 over 1.8, and I get 4.5 over 1.5. Well, this one is 3 over 1, I know that. And this one, let's see here, 1.8 times 3. Yep, 5.4. So this must be a 5.4. I can't read my own problems here. 5.4 over 8, so this is a 3 over 1. And we've got this side in ratio to this side, and this side is in ratio to this side. And this angle is in ratio to, or is the same as this angle there. So I must be using side, angle, side similarity to say these two triangles are similar to each other. But if I wanted to, I could look at this over here, and I've got 6 and 2. 6 divided by 2, that's 3 over 1 as well. I've actually got side, side, side similarity here, don't I? So it could be either answer, couldn't it? Well, that's the way that this is done typically, is they'll give you more than enough information, and you'll have to look at it and see which answers you've got in your answer choices. Sometimes it'll be this one. Sometimes it'll be this one. You just have to be careful with it. Okay? Now, for the part 2 for you guys, you're going to have one side splitting problem. What's it going to look like? Well, it's going to look similar to I think it looks similar to this type of a problem, where you'll have to try to find the answer to a value, okay? And they're going to ask you to prove why we know that we can use the side splitting theorem. And that's where you're going to have to use those corresponding angles, okay? Make certain you remember that. Okay, then you're going to have one scale factor, area, volume problem. And that one is going to look very similar to this problem right here. You're going to be given the the sides on two objects, and you're going to be given the volume, and it's going to ask you what the new volume is. But you're going to also have to give it the scale factor, the area of the ratio of the areas, and the ratio of the volume. Okay? And then here you're going to have one more, finding some missing side lengths using side splitting formula. So you'll have one more side splitting formula problem to work out. Okay? Those are the 3 problems you'll have on the Part 2 assignment. Now, after you finish that on Thursday and Friday, you're going to be looking at the next unit. And the next unit is unit number 4. Okay? And we're going to take up the concept of an arc and a chord. An arc is simply the outside of a circle between 2 points. So from there to there would be an arc. Okay? And if they wanted me to find AD, well, AD goes all the way across the circle like that. That is a chord, but it's a special chord because it goes through the center of the circle, so it's a diameter. PB goes from there to there. That is a radius. It is not a chord at all. Okay? Chords have to go all the way across the circle. How about BD? BD is a chord. How do I know the difference between that? See how it goes all the way across the circle? It's not it's not going halfway across the circle, or it's not stopping in the middle anywhere like PB is here. Okay? Look at angle BPD. B to P to D. That is called a central angle. Anything that has the center of the circle as the center point here, see how it's circle P, how it's got P here, that tells you it's a central angle. Okay? And we're going to learn about central angles in a little bit. Now it's asking about angle BDA. Well, BDA, A is on the edge of the circle here, isn't it? So that is called a inscribed angle, because it's totally inside of the circle and its vertex is on the edge of the circle. Okay? Now, how about point P? Point P is the center of the circle. How did I know that? It was telling me that right here. Circle P, that's the inside of the circle. Now let's look at some arcs. From B to D is an arc, B to D. And we would write that as arc BD, just like that. Okay? It's got that little curved line over it, not a straight line, but a curved line. Okay? Now, if I wanted to look at the arc that goes from C around the long way around the circle, all the way around to B, right now, room on my little pad here, C to B there, I could write that as CB, but there's two different ways of getting there. So typically what we do is if we got to go the long way around, we write CAB as an arc with 3 letters. Okay, that's telling you it's going the long way around the arc, long way around the circle. If you only see 2, it's taking the short path around. Okay, can you tell the difference between the two? It's a matter of, it's the long path or the short path. Long path will have 3 letters in it, short path will have 2. A chord goes all the way across the circle. Just a matter of being able to see it go across the circle. Okay. EF is the diameter of the circle. EF is a diameter of the circle. Goes all the way across. Okay. And GDE, well, D is the name of the circle, so it's a central angle, and it's G to D to E here is 105 degrees. Well, since EF goes all the way across, arc EGF, arc EGF is going to be equal to 180 degrees. Okay? But arc EG is only going to be equal to 105 degrees. Where did I get that 105? It's going to be equal to the same as the central angle that inscribes it, that makes it. Okay? So this is 105, but this is 180. So you can tell, to find arc GF, all I'm going to do is subtract 180 minus 105, and I'm going to get 75 degrees is arc GF. One more problem here. It says GDF is equal to 55 degrees. Well, where is GDF? GDF, that's 55 degrees. Okay? And they're asking, what's the measure of arc EH? EH is over here. See how this and this are the same length? That means that this arc will be the same length as this arc, 55 degrees. That's the way that works out. Now they're saying if angle CDE, that's this angle right here, is 120 degrees, what's the measure of arc EGC? Well, EGF, this is 120 degrees. That means that this one here must be what's left in 180, so this is a 60-degree angle there, right? And going from E through G back around to C, it's going to be 180 plus 60, so it's going to be 180 plus 60 is equal to 240 degrees. Last thing, the measure of arc EH. EH out here, they're saying they're changing the measurement here to saying that it's 43 degrees. What is the measure of angle GDF? GDF. Well, that's the exact opposite of what A was doing there. Okay? That would make this measure over here 43 degrees. That would make this measure, this angle in here, 43 degrees as well. So 43 degrees. What they're just trying to make certain that you catch is if this chord is equal to another chord on the circle, then the arcs are going to be equal. And if the arcs and the central angle are also equal, so the central angle would equal what the chord is equal to, and since this other, or what the arc is equal to, and since the chords that make those arcs are the same, then the chords are the same, or the arcs are the same measurement too. Okay? Well, this has been the Class Connect for this week, and I appreciate you watching this recording. Okay? These are the teaks that we've been trying to solve here. Most of this was dealing with the review that I did. We'll have some different teaks when we're looking at the circles and the circles and the arcs and things like that, but that'll come up next week. Okay? My secret word for today is treehouse. So when you watch this recording, send me a K-mail. Make certain you tell me that you're in geometry and that you watched the recording for this week and that the secret word was treehouse, and I'll give you credit for having watched the recording. Thank you, and I'll see you next week.